Hi guys, welcome to this video on elastic load balancing. Elastic load balancing is a technology that we can use to distribute connections that are coming into our applications to different back-end endpoints. And those back-end endpoints can be EC2 instances, they can be Lambda functions, and they can be IP addresses. So let's have a look at the way elastic load balancing works. So let's say we have two different availability zones, each with a subnet, and we've distributed 4 EC2 instances across those two subnets, and those are each running the same version of our application. So this is good for stateless applications. If each of these instances is configured differently, or if it has some specific data that's saved when a user initiates a session, then that's not really a good use case for elastic load balancing. So what happens with elastic load balancing is we put the load balancer in front of these instances, and then connections come in. So we have a listener which checks for the incoming connections using the combination of a port and a protocol. Then a user tries to connect to the single endpoint for the load balancer. So there's one endpoint for the load balancer, and you can definitely create Route 53 entries to point to that endpoint as well. So it might be your domain name. Like for example, in the labs, we're going to use dctlabs.com. So when the user puts dctlabs.com in, Route 53 resolves it to the elastic load balancer, and the elastic load balancer then forwards the connection to one of the backend instances. And you don't know which one, it tries to distribute it fairly evenly. But that's why each of your instances must be configured the same. If user 2 comes along now, the load balancer is most likely going to put that user on a different instance. User 3 comes along, connects, and goes to another instance as well. Now, what happens if an EC2 instance fails? Well, in that case, the elastic load balancer will take it out of service because it will notice that it's not responding to health checks. Health check is just the load balancer making a connection request to the EC2 instance, checking if it's there and responding. And if it is, then that's great, it's a healthy target. And if it isn't, it's an unhealthy target and it gets taken out of service. And in that case, the connection is obviously dropped and then re-established with a different instance. So this is a way to keep that load across your backend instances, and also it helps you with high availability because an instance can fail and your application will still work because the user gets directed somewhere else. So that's the basic theory behind load balancing. Now, there's a few different types of load balancer on AWS. There are actually 4 at the moment. Classic load balancer, the application load balancer, the network load balancer, and a very new one called the gateway load balancer. Now, the classic load balancer is the old generation. It is still available, but it's not being recommended by AWS anymore. The two that are the ones that we're going to cover in this course are the application load balancer and the network load balancer. The gateway load balancer is for some very specific use cases. I'll show you in the console. It's also very new and not even available in many sites or many regions at the moment. So the ALB operates at what we call the connection level. That means it's basically routing according to information in the content of the request at the HTTP, HTTPS level. So that's layer 7. So it supports something called path-based routing, host-based routing, query string parameter-based routing, and source IP address-based routing. Now I'll show you a couple of examples of what those mean shortly. It also supports instances, so EC2 instances. You can have IP addresses as a target, Lambda functions, and also ECS containers. Next, we have the network load balancer. So this is more at the connection level. It's really good for very high performance, low latency requirements. It's also good for doing TLS offloading. So it can offload those connections for TLS encryption. That's transport layer security encryption. So it routes based on information in the IP protocol data. And that's about layer 4. Now I'll show you a bit more about that as well in a slide coming up. You can have a static IP or elastic IP in each subnet for the load balancer. Now that's really good for if you need to whitelist the connections in your firewall. So maybe your customers or another site that you're running has a firewall, you're connecting to the load balancer, and once the DNS name is resolved to the IP address of the network load balancer nodes, so there are nodes in different subnets, then your firewall might be restricting that access, so you need to be able to whitelist the IP. So you need to know what it is. And in that case, you can have static IPs. So let's have a look at a bit more detail about the application load balancer. So let's say we have 3 subnets, each in a different availability zone. And in each of those subnets, we have 3 EC2 instances. We can then create something called a target group and group these different instances. A target group is used to route requests to the registered targets. So in other words, the load balancer will direct requests to a target group and the instances that are registered and active in that target group. So we have an application load balancer. It has a rule configured on the listener, and ALBs will listen on the HTTP and HTTPS protocols, so port 80 and port 443. So we now have a client computer. The client has put in example.com/specials into their browser. The connection goes to the load balancer, and the load balancer forwards the request to target group 1. And it's done so, it's made that decision about which target group to send the connection to based on information in the path of the URL. So in other words, the /specials has been used to determine that target group 1 should respond. So maybe that's a special application that's been put in place specifically for a special offer that the company is running. Next, the user goes to example.com/orders, and this time the ALB will actually route the request to target group 2 because /orders is configured in a rule to forward to target group 2. Now, this is called path-based routing because we're routing based on information in the path in the URL. The path is what comes after the example.com. So we've got /specials, that's the path. So /specials goes to target group 1, /orders goes to target group 2. Now, you can also do something called host-based routing. So here you're using the host header. In other words, this is the label that comes before example.com. So it's a subdomain essentially. We've got members.example.com. In this case, the ALB will forward to target group 3. And this is called host-based routing. So we're routing based on the host field in the HTTP header. As I mentioned before, targets can be EC2 instances, IP addresses, Lambda functions, or ECS containers. Next up, we've got the network load balancer. So we've got the same configuration. In this case, we've just got 2 target groups. The NLB is running, and we've provisioned elastic IPs for the nodes in each subnet. So the way that elastic load balancing works, whichever load balancer you're using, is what we're depicting here is actually the logical representation of the load balancer. What's happening physically is that in the subnets in each connected availability zone, the NLB has provisioned a node. So that means it has a presence running in each of the subnets, and that's what's used to actually forward the connections. Now, with the NLB, you can have elastic IPs for those nodes. So we can provision an elastic IP in each subnet, and that can be used then for whitelisting in client firewalls. The NLB listens on the TCP, TLS, UDP, or TCP_UDP protocols. So we've got a client again. And this time the client's put in example.com, and they've got routed to target group 1. So that's the default route. This time, the client has put in :8080. What that means is we're connecting to a different port. So in other words, what's happening is the network load balancer is listening on port 80 because port 80 is the default for HTTP. And we've configured here port 8080. And so the load balancer is listening on port 8080. In fact, in this case, we're using HTTPS, but we're using a custom port. So there would need to be a certificate configured as well. So a separate listener on a unique port is required for this routing. And then the load balancer is able to route connections for this particular port and protocol combination to a different target group. So that's the type of routing you can do with a network load balancer. In this case, requests are routed based on IP protocol data, not based on the host information in the URL or the path in the URL. With an NLB, targets can be EC2 instances or they can be IP addresses. Targets can be outside of VPC. So your target can also be a server that's running on premises in your data center. So that's quite a bit of theory. And what I'm going to do is in the next few hands-on lessons, we're going to build out an architecture and we're going to test the application load balancer and the network load balancer.